Okay, so we're going over lesson 2.5, quadratic equations with complex solutions. So some will have complex in this packet and some won't. Okay, so just to start off, again, we always want to approach it where sometimes we're going to use the x and the zero product property. I remember it was called ZPP. And sometimes we'll use the quadratic formula. Okay, and we can use the graph to also, or like Desmos graph, to confirm our answers. Okay, so here, I always want to try the zero product property first, so I'm going to try the x. And notice that this is a 1, right? So I can just go straight from the x to the factors, like these ones here. Okay, so I have negative 40 up here, negative 6. What two numbers multiply to 40 but add up to 6? Let me think that through. So let's start with 2 times 20. 3 doesn't work, but 4 times 10 and 5 times 8. Can I add or subtract any of these to get 6? Yep, I can do it with 4 and 10. So 10 and 4. And in order for 6 to be negative, at least one of the negative 10 has to be negative. Sorry, the 10 has to be negative. So now I can just plug that into the factors. So x plus 4. And then remember, your solution is opposite according to zero product property. So x equals 10 and x equals negative 4. Okay, so try that with this problem now. Okay, so now this one, remember that every time we solve quadratics, we want everything equal to 0, right? That's not equal to 0. So here, what I want to do is subtract 20 from this side so I can get that side to be equal to 0. Take away 20 from this side. Okay, so now I get negative 20. Okay, so now I can try like the zero product property, or I can try to work this out. Okay, so let's do a times c, which is minus 60, and then negative 11 down here. I know this is a bigger number, but it's possible we can figure it out. I'm just got to look at one number at a time. So over here, I'm going to kind of go through all the different possibilities. So 2 times 30, 3 times 20, 4 times 15, I think. Then 5 times 12, 6 times 10. These are all the different numbers I can multiply to get 60. Now, the other way to do this is like take 60 and just divide it by these numbers. And notice how I went in order. It went 2, 3, 4, 5, 6. I'm just guessing. And so I could do 60 divided by these numbers to get that number I multiply. So which of these could I add or subtract to get 11? Well, not 2 and 30, not this one. 15 minus 4, that's 11. That might work. So let's try that. So 15, 4, and then I want this, the bigger number, to be negative. Negative 15 plus 4 is negative 11. Negative 15 times 4 is negative 60. So that works. So remember, now that we have a coefficient bigger than 1, we're going to have to use the box. So remember, the first term goes here. Last term goes in the last box. And then I take those two terms I found. And then remember, I want to add the variable to it. Okay, so now what I'm going to do is I'm going to start with either this row here or this row here. Because I got to figure out, what do I put here and here? I know that 3y times y will give me 3y squared, but where does the 3 go? Does it go on the top or the bottom or the left? So if I look at 15 and 3 and say, what do those have a common factor? Well, yeah, I can divide both of them by 3. So that means I know that 3y goes here. And then if you look at it, 3 and 4, the common factor is just 1, so it's just y. Okay, so now 3y times what gives me negative 15? Negative 5. Y times what gives me 4y? 4. So there's my factors. So 3y plus 4 and y minus 5 equals 0. Okay, so I'll use zero product property, which says if I have y minus 5, that y equals 5 will give me a solution there. It's positive. And then if you guys remember the trick I've showed you guys in the other videos, you can either set this equal to 0 like this and then solve it and solve for y, or just cover up that first. If you have a number here in front of the y or that variable, just cover that up and say, okay, well, what would the answer be if it was just y plus 4? It would be negative 4. And then because I have a factor or a coefficient here, I put it over that number, 3. So it's negative 4 over 3 is the answer, or y equals. Okay, so now try it with that one. Okay, so now here, you guys might recognize these before when I've gone over this problem, that here I've got not 3 numbers like I do in these problems, but here I've got just 2, and they both have a common factor of y. So I can bust out my little 1 by 2 box, and then let's work on those factors. And the common factor here is y, and y times y gives me y squared, and y times 4 gives me 4y. So that means that if I factor this, I get y times 4y plus 4. And once you start to recognize it, you really don't need to do the box. You can kind of just go straight from here to there. Same thing even with like these problems with the coefficients 1, the first one. You can go straight from here to here if you want, once you kind of start to see the pattern and how it's done. Okay, so now remember, if I just have y, my first solution will be 0. And here, because it's plus 4, my other answer will be negative 4. Okay, so go ahead and try it with that one now. Okay, so now here, again, remember you want it to be equal to 0, right, when you're doing quadratics, because I got a square. Okay, so I want to subtract that from both sides. And notice what happens there. They both cancel out. So all I'm left with now is n minus 4n equals 0. And then literally it's like just like that problem. And I'm not going to use the box this time, since it's kind of the same thing. Okay, so I factored out at n because that's common. And so my first answer is n equals 0, and then n equals positive 4, because that's negative 4. Okay, so now this one, again, same thing. Want it to be equal to 0. So minus 4, and notice how those cancel out conveniently, right? Okay, so now I got 3t plus 15t equals 0. Okay, so now, similar to these in that they're both have t, but now also the coefficients have a common factor. So these both can be divided, those numbers can be both divided by 3. So 3 and t are a common factor. So I'll put those in front. So 3t times t gives me 3t squared. And then 3t times 5 gives me 5t. All right. Now, you might be wondering, well, what answer do I get from 3t? Well, what number would you multiply times 3 to get 0? 3 times 0. So that doesn't really change. And then here I get negative 5. Okay. Okay, so again, same thing. Okay, add 3, make it equal 0, and then it just nicely goes away. All right. Okay, now in this case, there is no common factor between 11 and 2, so I can't factor anything there, but I still have an x between both numbers, right? So I'll factor out that x and get 11x plus 2 equals 0. Now, what I can do here is first, I know that that's 0 for the first one. And then if you remember up here, like we were talking about that trick where you cover up that first number, I can do the same thing here. I can cover up that number, and I know that I would get negative 2 if it was just x plus 2 here. But since I have a number there, that goes in the bottom. And again, you can like set it that equal to 0 and solve for it if like that's confusing to you. Like just set it to equal to 0 and then solve for it, and you'll get the same answer. Okay. Okay, and then here, 0 is a solution to each of the following equations. Here, 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 and there. What do all of the above equations have in common that causes them to have 0 as a solution? Well, I want you to kind of figure that out. You look at each of these equations and what's causing all of these to end up with 0. Okay? All right, so now let's go and solve this equation. All right, so when you have these fraction equations where x is on the bottom, let's first like try to get this thing by itself by getting rid of that 5 or taking the 5 away from this side. So we're going to add the 5. And then we get, that cancels, we get 2x over x equals, was that negative 25? Okay. So now what we can do here is I am going to actually cross multiply. The way I do that, and the reason I'm cross multiplying is because I've got an x on the bottom here. Otherwise, I would probably not do that. So then I put that over 1. And so I'm going to cross multiply 2 times 1. And then x times negative 25. Okay, so I get negative 25x, and the last step is just divide by that negative 25. And so x equals negative 2 over 25, because I can't reduce that anymore. All right, so now, again, when I get these it's called a proportional problem, or it looks like a fraction, or you could also be called a rational. I would do the same thing I did over here, cross multiply. So we're going to cross multiply here. So first we'll do 4 times 5 minus x. And then 3 times x minus x plus 3. So that means I'm going to have to distribute. So first that's 20, then minus 4x. And then here's 3x. And here is 9. Don't forget to multiply both. But sometimes you guys forget to distribute to both. Okay, so now I got variables on both sides. Okay, I want my variables to be on the left. I always like it to be on the left. So that means I'm going to take away 3x from both sides. All right. And then I want my constants to be on the right, so I'll take away the 20. So let's see, this gives me negative 7. And this gives me negative 11. So negative 7 divided by 11. Okay, you can't reduce that, but it's a negative divided by negative. So x equals 11 over 7. Okay, so I get a fraction. No problem. All right, so now again, zero product property makes this pretty simple. So it's already kind of teed up for you, right? So that's positive 3, negative 5, positive 5. Boom, done. Those are super easy, right? Okay, so now let's move on down here. All right, so again, let's make sure it's equal to 0. So we're going to add 2 to both sides. We get 3x minus 4x plus 2 this time. Okay, so let's try the x. Let's set that up. So a times c, 6, and then negative 4 on the bottom. And what two numbers multiply to 6 but add up to 4? Well, the only numbers that multiply are 1 and 6 and 2 and 3. And neither of those will add or subtract to get negative 4. So what's my only other option? Well, looks like quadratic formula. Okay, so let's set that up. Okay, so remember my a is 3, my b is negative 4, and my c is 2. Okay, so I'm going to set that up. First, I got negative b, so negative times negative 4, then plus minus the square root of b squared, which is negative 4 squared, minus 4 times, remember that number is always 4, times your a, which is 3, times your c, which is 2. Okay, and then all of that over 2 times a, so 2 times your 3. Now you can kind of work this out step by step. So we got negative times negative there, so it's positive 4. And now negative 4 squared is 16. Okay, so now I'm going to multiply these out. So 4 times 3 is 12, times 2 is 24. So it's 16 minus 24 over 6. Okay, so now 16 minus 24 is going to be negative 8. Negative. Now, if I was to plug this into a calculator, I would get an error because it doesn't like negative square roots. That doesn't mean there's not a solution, though. So this is where we start getting into the complex solutions. We get imaginary numbers. Okay, so first thing we want to do, if you guys remember when Mr. Menard went over how to break down radicals, was we want to use birthday cake. Okay, so we're the perfect squares method. You want to go back and watch the video on how to do that for radicals from the lesson 2 point, the one that said like 2 point star star. Okay, so it was the last lesson. You want to review that. So what I do is I take the 8 and I put it in here, and we divide the smallest prime number, which would be 2. So divide by 2, and that's 4. Then I divide that number. What's the smallest number I can divide there? Well, that's 2. And that gives me 2. All right. And then what's the smallest number I can divide into 2? Well, 2 goes into itself, and I get 1. And once I get a 1 on the top, I get a birthday cake candle. That's why it's called a birthday cake. Okay, so there's my factors though. So now in a square root, what I do is I basically circle groups of 2. So if I have a group of 2, I just circle that group and I take one of those numbers and they go outside the radical. Just one. But then notice I didn't circle this one because I can only circle groups of 2 with a square root. So the one that's left over goes on the inside. The other thing I got to account for is that this is a complex number, imaginary number, when I have a negative, so I'm going to have 2i. I put an I on the outside. Okay, so that all that over 6. Now the next part of this, and again, if you did not watch the last lesson, you really need to in order to understand what's going on here, is complex numbers have 2 parts. So we want to actually split this up. So first, I'm going to take that 4 and put over the 6. Basically, what I'm doing is I'm splitting this into 2 fractions. Okay, and then over here I have 2i times the square root of 2 all over 6. Okay, so now what I can do is reduce this. So I'm going to have, reduce this becomes 2 over 3. And then here, what I'm reducing is only the 2 and the 6. I can't do anything with that square root. So if I was to reduce this by dividing by 2, then I would get 1 here and 3 here. So since it's just a 1 on the top, I'm just going to leave it as I times the square root of 2 over that divided by 2 is 3. And there's your answer. Lovely answer, right? You got 2 over 3 plus the square root of 2i, 2 times I over 3, or minus. Okay? Okay, so now this one, now I want to go back to the fractions, how to solve fractions. I think that was in week 2 in the first folders. And what I want to do is I'm going to take my denominator here, the first one, and multiply that times all of these. So I'll multiply 4 here, here, and here. Now if it's the 4 in the bottom, they just cancel. Same thing here. But if it's not 4 in the bottom, well, I'm going to multiply it. 4 times x. Doesn't automatically cancel. But notice it's 4x divided by 2. Well, that's going to be just 2x. Okay? Okay, so now, next thing I want to do is just solve the equation. Looks like a pretty simple equation, right? Okay, so now that becomes 2x equals 2. Divide by 2, x equals 1. Okay? Okay, last bit here, last side of the page. Okay, so now up here, again, we want to solve these quadratics. Okay, so what I'm going to do is I like my squared terms, the ones that have the x squared, always to be positive. So what I'm going to actually do is I'm going to add all of these to the right side. That way this ends up being positive. Okay, and then the rest will change signs. It just makes it all a lot cleaner. If I'm going to try zero product property, I don't want a negative square number. Okay, so add x, add 5, and then do the same thing to the other side. Basically just adding all of this to the right. So these all cancel, become 0. Okay, so then I ended up with, let's see, 3x. Let's actually kind of move this over, give myself some room. 3x squared plus x, and then I've got 5 and negative 1, so that's going to be 4. Okay, so now what I'm going to try to do is I am going to try and try the x. So 3 times 4 is on top, and a times c, and then on the bottom goes 1, because that's your b value. Oops, I'm sorry guys, you can't see that. Okay, so I got b. my b value in the bottom, a times c on the top. What two numbers multiply to 12 but add up to 1? Well, I think the one that will come to mind first is 4 and 3, because you're like, oh, well, 4 minus 3 is 1. But the problem with that is you can't have one of these numbers be negative. And they both can't be negative either. Because they're both negative, that equals -7. If only one of them is negative, then this would be a -12. So this isn't going to work. So we got to try quadratic formula. Okay, so what we're going to do is we're going to set it up just like we did the last one. So we got negative b plus and minus the square root of 1 squared minus 4 times your a, which is 3, times your c, which is 4, and then all of that over 2 times a, which is your 3. Okay, so now let's go through and simplify all this. Okay, so first negative times 1, that's -1. And then -1 squared minus 4 times 3 is 12. Times 4 again is 48. So then we have 1 minus 48. Well, that's going to be negative 40. What would that be? 47? Okay, you can always plug all that in a calculator if you want to figure that out. Okay, so now again, here we have another issue. We've got a negative square root, meaning that that's going to be an imaginary number. Now, 47, if you notice, is a prime number. There's nothing I can actually divide into 47. So I can't do the birthday cake method here to break it down, so I'm just going to leave it as it is. So let's bring this up here. So remember what I told you, if you had a negative, and just put I outside. Oops. And put that over 6. And now remember, imaginary number has 2 parts. So I put the 6 under the -1, split it up, and I put the 6 under the I times the square root of 47. And there's your solution. -1 over 6 plus I square root over 6, and the same thing subtracted. Okay? Okay, so now this one, again, I'd like to try to get this to be positive, so I'm just going to add it to both sides. I always want my square term to be positive when I'm solving these equations. It makes life a little easier. I mean, the fact is over here, I probably could have just gone ahead and plugged in that -3. The only thing is you got to make sure that it's equal to 0 no matter what. So however you start with it, you could have added the 1 to this side. In other words, in this problem, you could add the 2 to the side and then use -5, -2, and then whatever you end up with here and plug it into the quadratic formula. But you got to make sure it equals 0 no matter what, whichever way you do it. Okay, so here we add that cancels. Then we have 3x squared, then minus 2x, and minus 3. So again, I'm going to try to do the x. I'm just going to do it like up here. Okay, so a times c, -9, and then -2 here. Well, I'm already seeing that that's not going to work, because 3 and 3 are 1 and 9. That's not going to give you 2. So quadratic formula time again. Okay, so I'm going to set this up just like I did the last one. Okay, so negative times our b, which is already -2. So you'll see that becomes positive. And let's see, so we got -2 squared. So because it's negative, I'm going to put it in parentheses. Minus 4 times our a times our c. All of that over 2 times our a. All right, let's start simplifying. Okay, so negative, that's positive. Okay, so now I'm going to try to just figure this all out at once. So -2 squared is 4. All right, so that would be 4. And then over here we have 4 times 3, which is 12. Times 3 again, that's 36. And since we have a negative and a negative, it'll be positive 36. So it'll be 4 plus 36, which is 40. Okay, so then we end up with 6. So now what I'm going to show you is another way to answer this by using the Desmos calculator. Okay, so what do we do to figure out those solutions? I'm basically just going to type them out. So I'm going to get the fraction button, hit that fraction button, and do 2 first I'm going to do plus the square root of 40. And then over 6. So I'm basically just copying this down right here. Okay, so you can see my first answer is 1.3. Let's round it to nearest hundredth, so 1.39. So I'm writing that down in my paper now. And then all I have to do is just change this plus to a negative, and there's my other solution, negative 0.72. Okay, so there's my solutions. Now, you might be wondering, like, well, how do I check my answer? Well, an easy way to do this is to literally just take your equation that you started with, and after you've already set it equal to 0, and so after I set that equation equal to 0, it became 3x minus 2x minus 3. I'm sorry, 3 actually. I'm talking about this one right here. Okay, so then if I look to see where it crosses the x-axis, it should match my answer. If you look right there, 0.72 and 1.3, that's exactly what I got here. So then I know I'm right. So you can check your work pretty easily, but just by typing in the equation. Okay, so now let's go down to the next ones. Okay, so again, I want to try the zero product property, and I'm going to do this without the x this time. Okay, so remember this is 1, so I can just go straight to the factors. So what two numbers will multiply to negative 12, but add up to negative 1? Well, I know 4 and 3, if I subtract them, they'll give me 1. So that means that 4 has to be negative and 3 has to be positive. And then when I figure out my solutions, that's negative, so I get positive 4 for my solution. And that's positive, so I get negative 3 for my solution. Okay? And again, just remember, guys, you're doing this one, not that one. Okay, now this one, I think I wrote this one down incorrectly. Okay, so I got it. This is what I wanted to start with because I wanted it to look like that. Okay, so again, I want everything to equal 0. So I'm going to subtract 11x from here, both sides, and then I get 4x squared minus 11x minus 10 equals 0. Okay, so honestly, I don't even want to bother with the x right now. And now I'm thinking in my head, I don't know if there is a something that's going to work for that. And it just says solve it. It doesn't say you have to use zero product property. But because these numbers are kind of like, I don't really want to mess with it, I'm just going to go ahead and use the quadratic formula and just set it up. Okay, so I got negative b, so negative times negative 11, plus and minus. Remember, guys, you just got to go back in your last week's notes and look up that equation if you're wondering where all the quadratic formula comes from. Or just literally Google quadratic formula, and you'll see where what the formula is. Okay, so then b squared goes in here, or negative 11 squared, and then minus 4 times your a times your c. Okay, so negative 10 there. And then all over 2 times your a, so the 4. Now, here's what I'm going to do. I'm literally going to take this whole thing, and I'm going to use the calculator, Desmos calculator, to plug it all in. Okay, so I'm going to get the fraction button. I'll do negative times negative 11. And first I'm going to do plus, because remember, you have to do plus and minus. And then square root of negative 11 squared, and then minus 4 times your a, which was 4, and then times negative 10. And on the bottom, I wanted 2 times 4, which you could write a if you want. And look, boom, it already calculates my answer automatically, literally as I'm typing it. Like as I'm typing it, it's generating the answer. Pretty cool, huh? Okay, so my first solution is going to be 3.47, so let me write that down. And then my second solution, remember, all I have to do is change this to minus, and there's my second solution. X equals 0, negative 0.72. And what I want to do is actually verify that. So remember, I already set it equal to 0. So what I'm going to do is type this in here and just double check to make sure my answers are good. So what I'm going to do is click on wherever the x-intercepts are, And that matches my answer. So good to go. Easy way to check it when you're taking the quiz, right? Okay, so now here let's try, these numbers are more manageable. So I'm going to try zero product property. Let's see, two numbers that multiply to 10 but add up to 6. Well, the only numbers that multiply to 10 and then add up to 6. Oh, you know what? I think I actually wanted this to be something different. I wanted this to be 40. Sorry, that should be 40, not a 10. So two numbers that multiply to 40 but add up to 6. So I could go down the list. I could write it over here. So 2 times 20, 3 doesn't work, 4 times 10, 5 times 8. Well, if I do 10 minus 4, that will give me negative 6. So, but I want the 10 to be negative and the 4 to be positive. So that means my solution is positive 10 and negative 4. And now I want you to notice that this one is actually a repeat of the problem on the front. So accidentally we put that in twice. So you can try it again, or just copy your work down from the first one. That's fine. Okay, so here now you want to approach this like you're solving like any other equation. Okay, so first thing I want to do is get rid of. I almost want to treat this part of it like it's just y by itself. Like it doesn't have this like plus 2 and square thing. So what I'm going to do is get rid of one piece at a time. So first I'm going to start by adding 5 to both sides. I'm going to add 5, get rid of that. Equals 75. Now, if this was like 3y equals 75, what would you do to solve that? You divide by both sides by 3, right? So I can do the same thing here. Divide by 3, divide by 3, and then I get y squared, y plus 2 squared equals 25. Now, if you remember back from the quadratic equations folder from last week, when you have a square like this, and guess what? A little perfect square over here. Actually, it doesn't have to be a perfect square, but when you get binomial squared here, I can do the square roots method. So this is a method we don't use that often, but once you have just a binomial or a factor here that's squared, I can just square root both sides. Okay, so when you square root this, basically all you're left with is y plus 2. It basically cancels out the square. And the square root of 25 is 5, but then we got to remember that there's two solutions in these quadratics, right? And in this case, when you square root a number, you can have both positive and negative. So we put plus minus there. So now I want to subtract 2 from both sides. And now we have y equals negative 2 plus and minus 5. So that what it means is that to get my answers, I'm going to do negative 2 plus 5, which is 3. And then negative 2 minus 5, which is negative 7. Okay? You can try that with that one. Okay, so now this one is very similar to when we get to this step, except it's already set up. So all I got to do is square root both sides. So I get x plus 3. And when I square root 0, it's just 0. And there's no plus and minus 0. You can't have a negative 0 or a positive 0. It's just 0. So now all I do is subtract 3. And x equals negative 3. Okay, so now this one, you may be tempted to think, oh, I can factor something out. Kind of like when we were looking at those first ones on this page, how these all had like two numbers, but notice the difference. These both have a variable, t and t, x and x, or here, n and n, whereas here, it does not. This has x and this does not. So if this does not have x, here's what we're going to do. We're going to take this number and move it to this side, and actually this is one of the only cases where we don't want it to equal 0. So now we're going to subtract 49. We get x squared equals negative 49. Now, let's just write something over here to the side. Let's just say I had x equals 16, right, as my problem. What I do is I square root both sides. And I end up with 4 and negative 4. Because remember, plus and minus, right? So we have a negative. So here, what we're going to do is we're going to square root both sides. And we get x, and the square root of 49 is 7. However, because it's negative, we have to do I, because it's imaginary. You can't take the square root of a negative number, so it has to be imaginary. And we got to count that for the fact that we could have a plus or negative solution. So we have 7i and x equals negative 7i. So you could write it like this or like this. Either one is acceptable. Okay, so now here, let's make this equal 0 since we have 3 different terms, not 2 like this or like that as other cases. Add that to both sides. So now we get 3x is equal to, 3x squared plus 12x plus 9. Okay, now the other thing is, on this one I noticed that 3, 12, and 9 all have a common factor of 3. So what I'm going to do is actually factor out that 3. And now I have 3 times x squared is 3x. 3 times what gives me 12x? 4x. 3 times what gives me 9x? 3. So what I'm going to do now is I'm going to use the zero product property, or like the little diamond, and we're only going to factor this part, the x squared plus 4x plus 3, not the 3. We don't care about that anymore since it's outside. So now I got the 3 on top, 4 on the bottom. What numbers multiply 3 to add up to 4? 3 and 1. 3 times 1 is 3. 3 plus 1 is 4. So we get x plus 3, x plus 1. And so our solution ends up being negative 3, because that's plus 3, and negative 1, because that's plus 1. Okay? Okay, so the last problem's down here at the bottom. A little bit of review. So the first one, again, I'm setting it up very similar to that one. Now, notice I've got like y minus 3, and I've got this over here. So in order to graph this, because it says sketch it, right? I need this all equal to y. Because when you graph something, you might want it equal to y, just like that, right? Or like this, or like that. So what I'm going to do is I'm actually going to add the 3 to both sides. So then what I end up with is y equals x plus 5 squared plus 3. And notice that's in the graphing form now, just like this one. So I have the vertex, which is at, remember, negative 5, because that's plus 5, and positive 3. So that'd be like over here, be like negative 5, positive 3. And remember, it's this quick sketch. Now it's positive in the front, so that means it's going to go up. So I'm just going to make a quick graph. All I needed to do was find the vertex, and I'm done. Okay, so you do the same thing here. Okay, so now this one's a little bit special case. This is a rational or a reciprocal function, or rational, where you've got 1 over the x. So I'm going to do it with this one. So what I'm going to actually do is I'm going to rearrange this a little bit. I'm just going to put that part in front, because honestly, traditionally, usually you have that part in the front and then this part in the back. Now, when you have this kind of function, what you're going to do is that if this is x minus 2 on the bottom of the fraction, that means you're going to have an asymptote at 2, a vertical asymptote like this. And then the number after it will give you the second asymptote. So, and I'll show you what this looks like on Desmos after I finish here. So 1, 2, 3. So now I have another asymptote. So it's not really a line, it's just like a borderline. And so what this looks like is you always have kind of like a graph that kind of looks like a curve that gets really close to this asymptote, and then kind of bends and then starts to go down towards this asymptote. And then it has the same thing on this side. Okay? So, for instance, if you take a look at that, so 1 divided by x minus 2, and then plus 3. You can see that asymptote right there and right there. And if I actually put y equals 3 as a line, you'll see that kind of goes right through the middle. And if I put x equals 2, you can see that it kind of forms like another asymptote going straight up and down. Okay? Okay, so now the last part is identify the parent graphs of each of the following relationships and describe how the graph of each equation is transformed from the parent graph. Well, first of all, the parent graph is going to be identified usually by exponent a lot of times, or by special characteristics like this, like these bars. So if I see cubed, that means I know that this is a cubic function, which is just y equals x cubed. Now, with the -8 and the +2 and the 0.25, what happens after that? Okay, well, let's look at this example. I know I'm going to start with the inside, and then the inside of parentheses, if I have -4, well, it doesn't go left 4, it actually goes the opposite way. So it goes right 4. So this moves right 4. And then I have -3 on the outside, so then that means it goes down 4. Oops, sorry, down 3 is what I meant to say. I think I said down 4. And then here, what I do is I look at this number in the front. Now notice this one's less than 1, this one's greater than 1. We talked about this before in the last homework notes, that when this is bigger than 1, it becomes narrower or skinnier. Okay, if it's less than 1, it's the opposite. So in this case, the one that I made, it'll have a narrow shape to it. So the shape is narrow. Okay, so now this one we have bars with absolute value bars. So it's an absolute value graph. Actually, let me write that down. This is cubic, and this is absolute value. Okay, so the parent function is actually y equals the absolute value of x. Okay, so going from here to there, what's happening? Well, first, on the inside, we have +2. So it doesn't go right 2, but actually goes left 2. It goes the opposite direction. And then here on the outside, we have -3. So that goes actually down 3. Okay, and that's it. So go ahead and try that with those graphs.